Okay, so arithmetic sequences are sequences where you're adding the same thing every time or subtracting the same thing every single time. Whatever that number is called your common difference. So that's the fill in the blank on the first one. The terms of an arithmetic sequence have a common difference. So you're either adding the same thing every time or subtracting the same thing every time. So if you look at this first sequence, determining the next three terms should be pretty simple when you pick up. These patterns are pretty easy to pick up on as well. What are we doing to get from 3 to -2? What are we adding or subtracting, Kaylee? -5. And then the same is true from -2 to -7. -5. So the next term, we would subtract 5 would be what? -12. Subtract 5 again and you're at -17. Subtract 5 again and you're at -22. Okay? So the common difference, which we use D is -5, as Kaylee said. Given the first term and the common difference, find the next 4 terms. So a sub 1 is 1. And the common difference here is a positive number, so we're actually going to be adding this every time. So what's the second term if we're adding on a half? 1.5. The third term, 2. The fourth term, 2.5. And the fifth term, add on a half and you get 3. In B, we're back to a common difference that's a negative number again, which just means we're subtracting 3, subtracting 3, subtracting 3. So from -2, if you subtract 3, we're at -5. Subtract 3 from there, you're at -8. Subtract 3 from there, you're at -11. And that's the next 3 terms, so we have to go one more. Subtract 3, you're at -14. So that's just kind of getting your feet wet. That's as simple as it's going to come. There's 2 different ways to give arithmetic sequence formulas. You can do it recursively, which will always be taking the previous term and adding whatever your common difference is. Adding the half, adding the half, adding the half, or subtracting the 3, subtracting the 3, subtracting the 3. Or there's an explicit formula that you will write. And that's what we're really going to practice using the most. This formula is on your reference sheet. So if they want you to find the 15th term, n is 15, so a sub 15 would be the 15th term, it's going to equal whatever your first term is, plus you're going to add on the common difference 15 minus 1 times, which is how many times? What's 15 minus 1? 14. So to get to the 15th term, you would start with your first term, and then you add on your common difference 14 times. Okay? So your n is the numbered term that you're on, a sub 1 is your first term, and d is your common difference. And there's obviously 1, 2, 3, 4 pieces of information missing. You always need to know 3 of the 4 pieces of information so that you can find the missing one. So by telling us a sub 10 equals 8, what do you know here? What's n? 10. So n equals 10. So we're going to plug a 10 in right there. They also are telling you that a sub 10, now you can start by saying a sub 10 equals a sub 1 and get your d in there. But you're going to replace your a sub 10 with what number? 8. Did they give you your first term? No. They did tell us that we were on the 10th term, so we can use n as 10 Did they give you the common difference? It is 3. I forgot my plus sign. Sorry. Plus a sub 1 plus. So now we're just going to solve for the first term. So 8 equals a sub 1 plus 9 times 3 is what? 27. Subtract 27 from both sides. 8 minus 27 is, what is it? Negative 19. So based on the information, we now have found our first term, and they want the first 5 terms. So if the first one is negative 19, what? Okay, we'll come to it. There's definitely multiple ways, but depending on the information, that logic might be harder, which is why I'll always encourage you to go to your formula. But so negative 19, and then your common difference is 3, so add 3, add 3, add 3, add 3. So you can kind of go recursively from here. If I add 3 onto that, I'm at negative 16. Add 3 onto that, negative 13. Negative 10, negative 7. Is that 1, 2, 3, 4, 5 terms? Yes. Go ahead, Bo. Share it with us. Right. Which is wonderful because they gave you the 10th term, but they'll give you the 1000th term, and then good luck with that. So that's where I'm saying, you know, I like to start with smaller numbers so that you can prove to yourself and do it, what's the word I'm looking for? Manually, I guess. Do it manually backwards and you can still see that that's correct. Just giving you more faith in the formula so that when they do give you the 1000th term, you're not doing that manually. Okay? Or when the common difference is a crazy decimal, you know the Common Core. They'll make it nuts so that you can't do it manually. All right, so jump down to the next exercise. A sub 1 is 12. So that's going to go in for your first term. Your first term is 12, so that goes in there. A sub 5 is 20. So what goes in where for that information? They're kind of giving us 2 pieces of information there. They're giving us our A sub n number. What's that? 20. And they're giving us n is what? 5, because they're giving us the 5th term. And we're solving for D. So solving that out, subtracting 12 will give you 8 equals 4D, and then D equals 2. So again, I start with small examples. You could do that manually. And you could kind of say, okay, if my first term is 12, and then I have a second term, and then I have a third term, and then I have a fourth term, and then my 5th term is 20. Essentially, watch how I think through this manually, just to help enhance your understanding. I'm adding some common difference one time to get to the second term. A second time of adding that will get me my 3rd term. A 3rd time of adding that will get me to my 4th term. And a 5th time of adding that, or rather a first, second, third. Is that a 9? I'm writing things upside down. A 4th time of adding that will get me to 20. So if you were doing this manually, which I have no doubt you could all do, you kind of see why to get from the 1st term to the 5th term, I'm adding the common difference 4 times. So 12 plus some D value 4 different times is supposed to get me to 20. Yes? And that, obviously arranged slightly differently, is exactly what our formula just had us do. We start with our first term, and we add the common difference on only 4 times if we're trying to get to the 5th term, which was 20. Okay? But you don't need to do that. The formula obviously is doing that work for us. All right. So here's what I hate about the formula. What about a situation like this, where they tell us the third term is 8 and the 11th term is 12? Our formula, unfortunately, only is conducive if you know the first term. I couldn't, with this formula, figure out D right from the get-go, because I don't have the first term, and I obviously don't have D if I'm looking for it. So you'd have two missing pieces of information. Do you follow? So the formula is a little bit limiting, and I'm going to give you a way to fix that in a moment, but it's a little bit limiting because it forces you to know the first term in order to figure this out. And obviously here we are given information where we don't know the first term. Nathan, thoughts? We definitely could. Because there is slope and linear stuff going on. I have no doubt that you could figure it out. It's just giving you a way of doing it without having to think that complex every single time. And that's where our formulas are going to come in. So how do we find that? And again, the formula is written explicitly for the first term. This one and this one are both kind of based on the fact that it's knowing the first term. But I have written since a different formula where I change the ones to k's. So if you don't know the first term and you happen to know the third term, you can still do it. Where k can be 3, because you know the third term as opposed to the first, and n can be 11. So if n is 11, my formula, this formula, which is pretty much the same one that you're given, just knowing to change your ones to k's, so it's conducive to all terms, n is 11, so I'll say a sub 11, and k is 3 equals a sub 3 plus 11 minus 3 times d. And then they told me that a sub 11 was 12, and they told me that a sub 3 was 8. And then we can solve for d. So subtract your 8 over, gives you 4 equals 8d, and divide by 8, and d equals a half. Your common difference is your slope with an arithmetic sequence. And actually, go back to what Nathan said, if we had done the slope formula, y2 minus y1 over x2 minus x1, we would have gotten a half. So your common difference is your slope, if you want to kind of think of it that way. So now that we do know our common difference, we can go back here and find our first term. And then a sub n we'll just pick as this one. So we'll say n is 3. So a sub 3 equals our first term, which we're trying to look for, plus n, which is 3 in this case, times your common difference of a half. And we know a sub 3, they told us, was 8. I'll make my 3 minus 1, 2. And then 2 times a half, I'm just going to solve for a sub 1. 2 times a half is 1. So if I subtract 1 from both sides, my first term is 7. Okay? Unfortunately, the more we get into these, the more using these formulas is like a little bit of a maze. And it's feels more complicated than it is because of that. But we'll do enough practice where we'll work out all of these little kinks. For this one, they're giving us the first term as 12, and they're telling us the common difference and just asking us to write a recursive formula. So again, your recursive formula has two parts. You have to say what the first term is, so I'm going to repeat what they already gave me. First term is 12. And then to get any nth term, what do I do to the previous term? A sub n minus 1. What am I doing to it? What'd you say, Maggie? Subtracting 7, so just minus 7. And there's a recursive version of that arithmetic sequence. Okay? For the next exercise, I think there's a little bit of, I don't know if it's disagreement, but debate, I guess, as to does a recursive formula need to give you the first term? And some people will say yes. I think I'm on the side of the fence where I don't think so. I think you just need any term. So I would be fine with a sub 15 equals negative 10. And then to get any term, you just take the term before and add 2. But there is a camp of people that want the first term to be the given one. So using this information, let's find our first term. So given our formula, n is 15, so a sub 15 equals your first term plus n minus 1 is 15 minus 1 times your common difference of 2. And a sub 15 is negative 10, so I can just take that out and put a negative 10. So this is 14 times 2, which is 28. Are you all with me there? 14 times 2 is 28, so subtract 28 from both sides. And a sub 1 is negative 38. So there's a different camp of people that would say that you're required to have a sub 1 equals negative 38. Okay? Maggie. If it was on a Regents and it was multiple choice, I would almost guarantee that the multiple choice options would have the first term. So you should be able to find the first term. Okay? Open response. It hasn't come up yet, so maybe that's why it hasn't come up, because they know that there would be so many varying answers. I mean, if you can find the first term confidently just to be safe, but we all grade your exams, and I think we're all okay with it not having to be the first term. Okay? So I will hand out your homework now. Nothing new on this one. This one you just would have to, you're doing the same thing we did there. You just have to find your own D. And we've already done that today. So I'll send your homework around. You handed your quiz corrections forward. Again, all of your solutions for your homework are online. So if you want to make your life easier, I would just print out one of those and just keep it handy all together.